January 1943. The Carpathian foothills groaned under a crust of frozen mud and snow. Soviet tank crews fought not just the Germans, but the earth itself. Steel tracks slipped on the 15-degree slopes, engines screamed, and 20-ton monsters slid helplessly backward into ravines. The air was thick with diesel and fear. In the chaos, a mechanic wiped the frost from his goggles, staring at a stranded T-34 trembling on the incline. His name was Nikolai Ilyin, not a soldier by trade, but a tram driver from Leningrad. Before the war, he'd guided quiet streetcars down steep city roads, relying on a simple drum brake that never failed him. Now, watching tons of armored steel skid like ice, an idea began to take shape, one born not from textbooks, but from memory. The moment was brief. Shells whistled overhead, snow melted on glowing exhausts. Yet in that frozen hillside struggle, a streetcar driver's instinct would soon turn into a design capable of halting the unstoppable. That spark of civilian ingenuity would travel from muddy slopes to the Soviet engineering bureaus themselves, leading us to the story behind an accidental brake that saved tanks from gravity itself. By 1943, the Eastern Front had become a graveyard for machinery. Thousands of tanks littered the fields of Ukraine and the Western Soviet Union, not all destroyed by enemy fire. Many fell victim to the terrain itself. The war had turned into a brutal test not only of courage but of engineering. Soviet armor had to endure snow, mud, rain, and slopes that challenged even tractors in peacetime. The T-34, praised for its balance of armor, firepower, and mobility, often struggled on steep or icy ground. Its wide tracks gave it traction on soft soil, but its braking system, designed for open plains, lacked stability on inclines above 10 degrees. When a 26-ton tank lost control, it became a sliding fortress, impossible, able to steer or stop. Crews recalled watching comrades vanish into ravines when mechanical brakes locked, forcing them to abandon vehicles mid-slope. Reports of runaway tanks multiplied across the front. Engineers at the Kharkov locomotive plant and Gorky factory received endless field notes describing tanks that refused to stop. Wartime conditions allowed no luxury of redesign. Production lines couldn't pause for re-engineering, so frontline mechanics began improvising, welding extra levers, adding wooden blocks, or attaching field-forged wedges behind tracks. But these makeshift fixes rarely held under fire. By late 1942, Soviet command recognized the issue as a silent killer of mobility. While Western fronts dealt with open deserts and hedgerows, the East was dominated by elevation and weather. Tankers advancing toward Kharkov, Kursk, and Lviv met slopes slick with thawing snow and mud that clung like glue. Even the mighty KV-1, a 47-ton giant, often required towing by two smaller tanks just to climb a hill safely. The Soviet military's strength lay in adaptation. Across the war-torn USSR, civilian engineers, mechanics, and workers were called into service not only to fight, but to think. Posters read, "Every worker an inventor, every idea a weapon." It was in this spirit that countless small miracles emerged, solutions forged in workshops rather than laboratories. One such miracle would begin in a corner of a field repair station near Voroshilovgrad, where a group of tank mechanics worked under canvas tents surrounded by wrecks. Among them was Nikolai Ilyin, a volunteer mechanic in his 40s. Before the siege of Leningrad, he had driven trams across Nevsky Prospect, navigating steep urban streets and icy descents. His experience was mechanical by instinct, not theory. He had learned to feel motion through vibration, to hear strain through the hum of metal. During a particularly harsh January repair, Ilyin noticed how the tank's steel tracks resisted motion when a certain balance between pressure and release was applied. It reminded him of the tram's magnetic drum brake, which slowed massive streetcars by controlling magnetic resistance rather than friction alone. To most soldiers, the observation was meaningless, but to a man who had spent decades pulling levers through snowstorms, it was revelation. He shared the thought with his superior, a young engineer named Lieutenant Orlov, who was skeptical but desperate. Together, they sketched a crude adaptation using scavenged magnet coils from destroyed communication trucks. It wasn't elegant, but it suggested a system where braking could be controlled progressively, distributing resistance evenly through the drive mechanism, preventing skidding. The first test failed. The tank jolted and locked midway up a slope, but the idea wouldn't die there. Ilyin adjusted the coil alignment and recalibrated the manual lever sensitivity. When they tried again, the tank halted smoothly on the incline. No skid, no slide. Word spread among nearby crews. Soldiers began to refer to it half-jokingly as the streetcar trick and be known. As to them, that small demonstration would soon capture the attention of engineers far from the front lines. The Soviet Union's network of design bureaus, particularly those linked to the People's Commissariat for Tank Industry, routinely reviewed field innovations for possible standardization. Within weeks, sketches from Ilyin's group were passed through repair brigades to local factory representatives. What began as a field experiment on a frozen hillside would soon reach the desks of men designing the next generation of Soviet armor. The question wasn't whether the system could stop a tank. It already had. The question now was whether it could be built at scale. In early 1943, Soviet factories were in a state of relentless motion. Production never slept. The clatter of presses and welding torches echoed across Uralvagonzavod and the Gorky automobile plant. Every rivet, every screw was another step toward survival. Engineers barely had time to eat, yet even amid exhaustion, reports of frontline innovations were treated with the seriousness of weapon intelligence. When news reached the Gorky plant about a streetcar-style braking system tested near Voroshilovgrad, the reaction was cautious curiosity. The idea sounded absurd, using tram technology on tanks. But the Soviet design philosophy valued results over pedigree. If it worked in the field, it deserved attention. The wartime directive known as the Order of Field Modifications had authorized local engineers to adapt or improve designs without central approval, as long as they reported measurable performance gains. This was how many small but vital innovations entered Soviet military production. The engineers reviewing Ilyin's sketches noted an intriguing simplicity. The concept did not require new parts or advanced materials, only the rearrangement of components already available. The mechanism was essentially an adaptation of a magnetically assisted drum brake that could regulate braking force through current modulation. The streetcar driver's idea was not a reinvention of physics. It was an application of civilian mechanical intuition to a military problem. To confirm its validity, the Kharkov armored plant ordered a controlled test using a modified T-34 chassis. The prototype incorporated the adjusted braking system supported by standard hydraulics and assisted by a small electromagnetic coil adapted from generator stock. In a controlled trial, engineers positioned the tank on a 15-degree incline coated with ice and oil to simulate battlefield conditions. Observers expected failure. Instead, the tank slowed evenly and stopped in place. Not a skid, not a slide. The results shocked the attending staff. They had watched countless machines succumb to gravity, but this one held still, its tracks humming softly with electrical resistance. Field commanders called it a miracle of friction. Though the truth was far more mundane, it was the product of a man who once stopped to rams at crosswalks. The Soviet command began quietly disseminating the design among repair workshops, encouraging further tests under combat conditions. Because of the scarcity of materials, the adaptation was implemented only in select units, mainly tank regiments operating in mountainous or hilly terrain near the Carpathians and Caucasus. For many crews, the addition was life-saving. Reports from these regiments described significant reductions in slope-related accidents. In some cases, the system allowed for stealthy halts on inclines where older braking systems would have groaned or screeched, revealing positions to German artillery spotters. While the Soviet press never publicized this small innovation, it became a symbol of practical wartime ingenuity inside engineering circles. Ilyin himself remained at the front, unaware that his sketches were circulating through the industrial network. The Soviet Union rarely highlighted individual inventors during wartime, preferring collective credit. Yet within the pages of technical memos and repair reports, his name appeared repeatedly: Ilyin's braking principle, or simply, the Leningrad method. By late 1943, field engineers had refined the concept further. They introduced a compact lever control, allowing drivers to engage the brake progressively rather than suddenly. This prevented the mechanical shock that often fractured gear teeth in emergency stops. The combined hydraulic electromagnetic system provided far smoother operation than previous mechanical-only setups. What began as a field improvisation was gradually integrated into production modifications. Though it never received a formal designation, traces of Ilyin's concept appeared in late-war blueprints for the T-34-85 and post-war models like the T-44. Soviet archives later described it under the term gradient braking adaptation. More than a technological breakthrough, it reflected a mindset, the merging of civilian skill with military necessity. It was the unspoken bond between factory and frontline, where a tram driver's instinct could influence the fate of armored divisions. The innovation also carried a moral weight. At a time when Soviet cities lay in ruins, the story of an ordinary worker creating a battlefield solution resonated with engineers struggling under impossible conditions. It became a quiet reminder that intellect and survival were intertwined, that even the smallest insight could alter the trajectory of war. By the winter of 1943, the accidental braking system had proven its worth. But its true measure would come not in workshops or factories. It would be tested under fire when tanks rolled once again onto frozen slopes, this time with a hidden ally beneath their steel hulls. The next chapter would reveal how a streetcar driver's invention met the battlefield, where every hill became a proving ground for human ingenuity. The human story behind the so-called accidental brake began not in a design bureau, but in the silence between air raid sirens. Nikolai Ilyin was one of millions drawn from civilian life into the vast machinery of total war. In peacetime, he had memorized the rhythm of Leningrad's tram lines, the shudder of iron wheels, the pull of electric current through wire. His skill was balance, not battle, yet war had turned him into something different, a man who could see potential where others saw scrap. His adaptation was born from empathy as much as experience. Ilyin had watched soldiers die because tanks slid backward off frozen ridges. He wasn't trying to innovate, he was trying to save lives. That instinct, to apply the familiar to the unimaginable, defined the quiet genius of Soviet wartime engineering. In his hands, the technology of public transport became an armor-saving mechanism. Technologically, the idea was deceptively elegant. Tram systems used magnetically assisted drum brakes to control heavy vehicles on steep gradients. By converting electrical energy into resistance, they avoided the jerking halt of mechanical friction. Ilyin simply extended the same principle to a tracked platform. Using scavenged generator coils and modified hydraulic linkages, he created a braking system that distributed resistance evenly across the transmission. The result was a stable, progressive deceleration, something Soviet tanks had never achieved before on steep ground. What made it remarkable wasn't sophistication, but adaptability. It could be built from existing parts, installed in the field, and maintained without new supply chains. The genius lay in understanding function rather than form. Soviet engineers later noted that Ilyin's concept exemplified the wartime philosophy of rational minimalism, solving problems with the least possible material and time. His colleagues described him as quiet and practical, rarely speaking unless he was certain of something. Yet in that silence, he carried an understanding that bridges the gap between the ordinary and the extraordinary. His brake system was not a flash of brilliance but the product of observation, the kind that only years of street-level experience could teach. It was this intersection between human experience and industrial necessity that gave birth to one of the most practical small innovations of the Eastern Front. On the battlefield, Ilyin's innovation changed more than mechanics. It changed tactics. Tank commanders who once feared steep terrain began to see opportunity. Before the modification, Soviet armor often avoided hilly positions, limiting movement to flat approaches. With the new braking control, tanks could pause mid-slope, stabilize, and fire without sliding backward. This allowed Soviet crews to use elevation for ambushes and defensive fire, advantages that once belonged almost exclusively to the Germans. Reports from the 10th Tank Corps noted that vehicles fitted with Ilyin's adaptation could hold their positions during counterattacks in the Carpathians, providing a firing platform on gradients previously considered impossible. This new capability did not win battles by itself, but it shifted confidence. Crews began trusting their machines again, and in a war where morale could decide survival, that trust was everything. There was also a moral dimension. The story of a tram driver influencing the battlefield carried symbolic weight within Soviet propaganda circles, even if it was never officially published. It echoed a central wartime ideal, that the Soviet citizen, worker, farmer, teacher, could transform struggle into strength. To engineers and soldiers alike, it became a quiet legend told in workshops and mess tents. If a streetcar man can stop a tank, they would say, then anyone can hold the line. The Germans, unaware of this small modification, were puzzled by the sudden improvement in Soviet maneuvering on slopes. Reconnaissance units noted tanks holding positions on icy ridges without visible support vehicles. It seemed trivial to outsiders, but it altered the tactical rhythm of engagements. Soviet armor could now maintain staggered formations on uneven terrain, preventing the chain collisions that often occurred when tanks lost control. Behind the metal and machinery, Ilyin's break represented something larger, the fusion of human memory and mechanical instinct. It was the triumph of adaptation under pressure. His solution bridged the distance between a peacetime tram track and a battlefield slope, showing how survival in total war depended as much on imagination as on firepower. And soon, that imagination would be tested under the harshest possible conditions, in the winter battles where tanks met gravity and gunfire at once. February 1943. The war had settled into a brutal rhythm across the Ukrainian front. Snowdrifts as tall as men lined the roads, and engines sputtered under ice. Near the outskirts of Kharkov, the 179th Tank Brigade prepared for an assault on a ridge occupied by German anti-tank guns. The slope was treacherous, a 15-degree incline glazed with half-melted frost and oil from destroyed vehicles. To advance here was almost suicidal. For months, Soviet tank crews had dreaded these inclines. Once momentum broke, tanks slid backward like giant sleds, smashing into vehicles behind them. But this time, among the formation, several T-34s carried a quiet modification, an adaptation no one outside a few engineers fully understood. It had been installed by a small team of field mechanics under instruction from a recent technical circular. Brake mod, Ilyin, experimental. As the dawn broke over the ridge, the first wave rolled forward. The roar of engines drowned out the wind. Shells whistled overhead, exploding in plumes of white and earth. Tracks chewed through frozen mud, and the incline began to claim its first victims. One tank slipped, another ground to a halt. The crews with standard brakes fought to control descent, their levers jerking uselessly in their hands. But then, from the left flank, something unexpected happened. A single T-34 climbed steadily, its treads glistening with ice. Halfway up the slope, it paused and stayed still. The driver, Sergeant Kravchenko, eased back the throttle and engaged the new lever. The tank held firm. Behind it, others equipped with the same system followed, stopping at measured intervals, forming a staggered line across the gradient. The ridge, once impassable, became a stable platform. From below, commanders watched in disbelief. The braking system allowed crews to halt mid-ascent, fire, and then advance again in controlled bursts. It was as if the tanks had gained a new sense of balance. German gunners, accustomed to Soviet vehicles sliding into their line of fire, now faced armor that moved with surgical precision. The defenders, confused, shifted aim. But the brief hesitation was enough. Soviet shells tore through their positions, silencing the ridge one gun at a time. Within an hour, the brigade had secured the slope. Reports noted minimal mechanical failures, a rare miracle in winter warfare. When the surviving engineers inspected the vehicles afterward, they found the modified braking systems intact, their coils barely warm. The data was undeniable. Tanks equipped with Ilyin's adaptation showed over 80% fewer slope-related malfunctions than those with standard mechanical brakes. The event quickly reached divisional command, then the People's Commissariat for Tank Industry. It was not celebrated with fanfare, wartime secrecy forbade that, but in technical bulletins and brief memoranda, it was recorded with simple precision. New braking method proved effective on icy gradients up to 15 degrees to be observed for replication in other fronts. The battlefield success gave the innovation a new life. Copies of the adapted system began appearing in frontline repair depots from Kursk to Bryansk. Mechanics improvised, modifying the principle to suit different vehicles. T-70 light tanks, Su-76 self-propelled guns, even heavy KVs when spare parts allowed. For the first time, Soviet tankers could rely on a controllable stop during uphill combat. For Ilyin, still stationed with his repair crew, news came quietly. His commanding officer read aloud a dispatch from Moscow, recognizing the innovative brake control mechanism developed in the field by Comrade Ilyin and associates. No medals were mentioned, only acknowledgement. Yet for a man who once guided passengers through city streets, it meant everything. The test at Kharkov became a whispered reference point for engineers across the front. It wasn't a grand breakthrough like sloped armor or diesel engines. It was humble, mechanical, and utterly practical. But on that frozen February day, it changed how Soviet armor moved through the landscape. It transformed terrain from an enemy into a challenge that could be met head-on. And as the Eastern Front rolled into spring, word spread of this new reliability. Tank brigades advancing into the highlands of western Ukraine began to request Ilyin-type controls. What began as one man's memory of tram brakes was now quietly reshaping the Soviet Union's ability to fight on uneven ground. Yet the full extent of its success and its recognition would not come until the following months, when the system faced its hardest test under even steeper conditions. Spring 1943 brought thaw. The dreaded Rasputitsa, the season of mud. The frozen ground that once carried the weight of armies now turned to rivers of sludge. Tanks sank to their hulls, supply trucks vanished into ditches, and entire offensives slowed to a crawl. But for Armo, Red units fitted with Ilyin's modified braking system, something unexpected occurred. They began to perform better, not worse. The mechanism that had once saved tanks on icy slopes now proved invaluable in mud. Where conventional brakes seized under water and grit, the magnetic drum adaptation distributed stopping power without direct friction. It meant fewer jammed parts, smoother halts, and less strain on transmissions. Crews noticed they could approach steep embankments and marshy terrain with control previously unimaginable. In April, a test conducted by the 2nd Guards Tank Army near Belgorod documented a remarkable statistic. Tanks with the modified system completed gradient maneuvers 23% faster and suffered 60% fewer mechanical brake failures. It wasn't an official trial, just a field commander's initiative, but its findings circulated rapidly through Soviet technical channels. When the Battle of Kursk loomed in July 1943, every advantage, no matter how small, was vital. Among the thousands of tanks that would clash in that vast mechanized inferno, only a fraction carried Ilyin's adaptation. Yet even in that chaos, engineers noted something unusual. Tanks with the modified brake were less prone to reverse drift, a dangerous phenomenon when vehicles lost traction while firing on slopes. Crews could stabilize more quickly, maintain firing elevation, and reposition faster under incoming fire. None of this decided the outcome of Kursk. Strategy, numbers, and courage did. But in the margins of the Soviet after-action reports, quiet phrases appeared. Superior control on gradients observed in modified vehicles. Stable hold during turret rotation. Those few lines, buried beneath columns of losses and ammunition counts, were the only traces of Ilyin's impact on one of history's largest tank battles. Meanwhile, in the rear factories, the innovation took on a life of its own. The Gorky plant integrated elements of the design into the post-battle repair program, streamlining the electromagnetic coil system and refining hydraulic balance. By late 1943, engineers had drawn up a simplified assembly that could be fitted to both new and existing tanks with minimal disruption to production. In correspondence between design engineers, preserved today in the Central Archive of the Russian Federation, one memo reads, "This adaptation demonstrates high potential for gradient operations. Origin attributed to field mechanic Ilyin. Simplicity and repeatability warrant wider evaluation." It was rare praise in an environment defined by secrecy and urgency. The innovation did not revolutionize Soviet tank design overnight, but it was quietly absorbed into the DNA of future developments. The post-war T-44 and T-54 series would both employ more sophisticated, magnetically assisted braking concepts, direct descendants of Ilyin's wartime improvisation. By the end of 1943, the tram driver's idea had traveled further than he ever would. Across the front, soldiers began to recognize a new mechanical rhythm beneath their feet, a smoother halt, a steadier pause before firing. In the noise of diesel and gunfire, it was almost imperceptible. But for those who drove, it was the difference between panic and precision. For Ilyin, there was no celebration. He remained stationed at a repair depot outside Poltava, continuing to patch up the very tanks that carried his design. In letters to his wife, later archived, he wrote simply, "They say something I made has gone to the big factories. I hope it helps the boys climb without sliding back." It did more than that. It helped them hold ground when physics and fear conspired against them. It proved that invention could emerge not from privilege, but from necessity, from the mind of a man who once stopped streetcars on icy mornings. By the time winter returned, the brake that began as an accident had become a silent partner in Soviet mobility. Few would ever know its origin, but on every frozen hill where a tank held its ground, the legacy of a streetcar driver from Leningrad lived on. measured not in glory, but in grip. When the smoke of 1943's campaigns cleared, the Soviet Union began taking inventory of its war, not just in lives and land, but in lessons. Engineers compiled thick reports of every successful field adaptation, no matter how small. Among the pages filled with armor thickness data and turret performance graphs, one recurring note appeared: improved slope control via field braking mechanism, Ilyin adaptation. It was hardly headline material. No medals were awarded, no parades held. But within Soviet engineering circles, such acknowledgement meant permanence. An idea that survived a year of testing, combat, and mechanical review was not discarded. It became part of the invisible architecture of future machines. The innovation's greatest contribution was its simplicity. It required no new alloys, no redesign of the transmission, and no complex electronics, only a rethinking of resistance itself. Wartime tank production thrived on repeatability, and Ilyin's system fit that philosophy perfectly. In time, factories would adopt modified versions of his principle, refining the electromagnetic control and integrating it into newer braking assemblies. On the front, soldiers felt the change before they read about it. Tankers spoke of smoother halts on inclines, of not feeling the familiar lurch when braking on mud or snow. For them, the improvement was not technical but human. Fewer accidents, fewer collisions, fewer comrades crushed under the weight of their own machines. For Ilyin, the outcome was quieter. After the war, he returned to Leningrad and resumed his work with the city's tram system. Colleagues later recalled a man who spoke little of the front but occasionally smiled when streetcars stopped perfectly at a slope. He never patented his design, never sought recognition. His creation had already served its purpose. It had saved lives when saving lives mattered most. The war had turned him from driver to inventor and back again. Yet in that circle lay the story of thousands of ordinary Soviet citizens, men and women whose civilian minds kept the Red Army's machines alive. By 1944, the ripple effect of Ilyin's work could be traced through Soviet industry. Factories in Nizhny Tagil and Omsk introduced gradient braking calibrations into their maintenance protocols, referencing the same current distribution principle that Ilyin had first applied in the field. Engineers continued refining the design using copper alloys and improved insulation to stabilize performance in extreme cold. These developments would later influence the braking assemblies of post-war models like the T-54 and T-55, machines that defined Soviet armor for decades. Yet even as his concept evolved, Ilyin's name quietly disappeared from official records. Wartime documentation rarely credited individuals for single inventions, especially those who were not professional engineers. But among tank crews, his legacy lived on in stories, told around repair fires, passed between generations of mechanics. They spoke of the tram driver who taught tanks how to stop, a legend whispered with pride and humor. In the years after victory, Soviet military historians revisited thousands of such wartime improvisations. Many were forgotten footnotes, but a few, like Ilyin's, endured because they had fundamentally improved survival. A 1946 technical digest by the Uralvagonzavod Design Bureau listed it plainly. Field modification for braking stability adopted 1943, value proven. There was no emotion, only acknowledgement, the Soviet way of enshrining success. The adaptation's influence extended far beyond combat. Civilian industries learned from it too. Soviet transport engineers studying post-war tram and trolley systems drew upon wartime advancements in electromagnetic braking. The line between civilian and military design had blurred forever. By the late 1940s, Ilyin was one of countless citizens who had returned to quiet obscurity, their innovations absorbed into the larger machinery of reconstruction. But each time a tank held its ground on uneven soil or a tram halted smoothly on a steep street, a fragment of his wartime intuition endured, invisible yet indispensable. History would remember the battles, the generals, the tanks themselves. Few would remember the man who made them stop safely. Yet without him, many would never have moved forward again. War often celebrates those who advanced, commanders who led charges, engineers who built faster engines, armies that pushed forward. Yet progress in war also depends on those who learned how to stop. Nikolai Ilyin's accidental brake system stands as one of those quiet revolutions, born not from strategy, but from necessity, from a man who simply refused to watch his comrades die because steel could not hold a slope. His story reminds us that the Second World War was not only fought in great offensives or on maps crowded with arrows. but in moments of individual problem-solving, where ordinary people turn daily knowledge into tools of survival. A tram driver's understanding of friction and current flow became a weapon as decisive as any cannon, saving lives through control rather than destruction. In the years. At way, Ilyin's contribution captures the deeper truth of total war, that it transforms everyone it touches. The boundary between civilian and soldier dissolves, and the ordinary becomes essential. Every factory worker, every repairman, every streetcar driver carries within them a fragment of resilience that shapes the machinery of victory. Today, no museum plaque bears his name, and no parade honors the man who taught Soviet tanks to stand still. But every time a tank halts safely on a hillside test track, every time a machine obeys its operator instead of gravity, his logic lives on, a reminder that innovation is not always born in laboratories or war rooms. Sometimes it begins with a man in the snow, staring at a sliding tank, remembering the grip of a tram wheel on a wet street, and deciding that even in war, control is the truest form of power.